Hi everyone. Today is the last session of the QGIS guide, which will take you from beginner to advanced level. So let's move directly towards the contents which we are going to cover today. So let's move to the next slide. So actually, if you can see in this slide, I just make it into pictures just to make it more clear for you. For example, the first part we are going to explain of how to create auto polygons. For example, if you have many points in the map, if you zoom in here, let's just zoom in. For example, assume that you have many points in the map and you would like to create a polygons for this equivalent city name for each and every single point. Those can be auto-created. And second point, for example, if you would like to categorize all these new polygons which are being created, auto polygons, by color. This is the second point. The third point here, which we are going to discuss, it's about how to create a meaningful heat maps. I'm going to explain two different methods. For example, this is one of the methods we are going to explain. Then here, this one we're going to explain how to use Voronoi tool to, for example, to generate a useful insight. And this one, for example, here we can identify the area of influence. This one, for example, presenting a traffic area which having the highest traffic and so on. And this is even by charts showing the distribution. And here we are going, which is also very useful part. Here also from dots or points, you can also identify the areas where you're having weak points or whatever, or you can make a clusterization based in, as you can see here, hexagons, or even you have different methods, and this also can be done, and then you can categorize this one based on the speed or whatever metrics you have in your data sets. So this also will be useful because this one will be combining many other inputs as well. The last part we are going to explain, it is actually related to how, for example, to calculate the distances between two different data sets and how to draw lines, as you can see here, and also how to make kind of polygons to create these polygons. Then we'll have just quick explanation of how to generate plots using QGIS. So now let's move forward and see what we can do today. Hi. Now let's start with the first part of the today's session. Actually, in the first part, we are going to start with this point, which is to polygon creation and categorization. So assume, for example, you have points like this categorized with different colors. Each color represents a different city. So let me first explore the data which we have. Then we can show how we can create. So right click here in this. This is called random point. This is where I'm going to use. Open attribute table. Then you will see that each point, see the site ID represent a point in the map. Each point representing a city. So actually what we need to do, we need now to create for each of those cities a polygon, and we have a boundary with this polygon. So let me show what we are expecting to get. So these all the points. So what I'm expecting to get, for example, if you click here, now I have boundary for each and every single color or city, different polygon being created. This is we're going to do it like instead of manual, we'll just do a automatic way. This is the first point. Then we need to categorize it, for example, by color, like this. For example, if you hide this one, then we'll have this kind of, as you can see now, it's being categorized by different colors. And this is actually where we're going to use one tool called Voronoi tool, with the Voronoi plus the Solve tool. Actually, this Voronoi tool, it's actually very commonly used method, and this is based on proximity, like where each point will be associated with a unique polygon. For example, if you have one site, it will have, or you have 10 sites, each point of those sites or sites will be represented as polygon. And the most common use cases for the Voronoi in general, that it can be used, for example, for as this one to categorize your areas, for example, whatever areas you have, or city, or names, or tag, or whatever. And also the other one method that you can be used to identify the area of influence, for example, the highest traffic area or whatever. And this is will be discussed in the second part of this session. So now let's jump and check how we can convert these random points, which have it in the map, into boundary and so on. So as mentioned, we need first to use one tool under the processing toolbox called Voronoi. Actually, if you search here in the processing toolbox about Voronoi, you'll find it usually coming Voronoi polygons. It's under vector geometry. And just like to recall, whenever you cannot find this processing toolbox, if you, for example, close it here, there is two methods to get it. Even from the processing in the top right here, then you can just click in the toolbox, or you can do it even from here, view, then under the tool panels, you'll find also processing toolbox. This is in case if somehow you didn't find this one. So now let's use the Voronoi points which have it to get this kind of auto boundary. So search for Voronoi. It's called Voronoi polygon. So you will just click, if you check the description, just saying that this takes a point layer, which we have it. This is point layer, and generates a polygon layer. Then it will generate for each and every single point. So now what I'm expecting as a first step, I have 100 or 1,000 of points. Each point will have a polygon. Okay, so let's see what we'll get. So the first point, if you look into that, this is selecting my layer, which I'm already want to do. It's called random points. Actually, it's because I was clicking the layer itself. That's what's coming here. So in all cases, you can just select it from here. So now you have one parameter here called buffer region. Let me explain by practical example. If you click this one, run. So okay, now let's close and see again what we have. If you zoom in now, you'll find that each and every single point will have a polygon. For example, this point having one polygon, boundary, and so on. And this is not yet what we are looking for, to have a classification by the city name, right? So this is the first idea about Voronoi tool in general, that it creates a polygon for each and every single point. Now let me explain to you the meaning of the parameter which was saying buffer. If you look into zoom out here, so okay, now if you look into here, for example, you will have zoom out again more. You will find that you have some boundary points, this one and this particular layer points there, this one, this one. See now, because I was giving 0 for the buffer, it's not crossing the boundary of these points. This is the end point. So in case, for example, you would like to extend this polygon more here, in this case, you can use this buffer region. So I just click again on Voronoi polygons, this under processing toolbox, and this one, for example, you can now select your layer, which is random points, and give, for example, 20% extend. So I'm expecting to have a larger now polygons as extension. This one will come to the left here, and also same for the other sides. So just run it and let's see what we'll have. Now, if you look into that, you'll find that another one being created. So this is just to give you a quick idea, and this will be based on your requirement whenever you create any insight. So for now, let me hide this one and start working to try to reach into creating a boundary for the city based on the city name. So far, we create a boundary for each and every single site. So now here, where is the second tool, which is called dissolve, and this will also under the vector geometry here. You'll find it here. It's called dissolve. You'll find it here. This particular tool called dissolve. So you can, the easiest way just to search this one. So it's called dissolve. I will just double click. It's under vector geometry. And now this dissolve tool, actually what it do, it looks into all the points, with all the polygons which you have it, or which being created in the map, and you can classify or dissolve these polygons into, for example, one instead of 10 polygons, into one only particular polygon based on a given field. So now you need to change this Voronoi polygon too. You need to classify it now. You need your boundary based on city, right? So now what we need to do, just go to the dissolve fields, double click three dots. Then you'll find here all your options within your data sets. So in my data sets or data tables, I have site ID and city name. I would like to dissolve all these polygons by city name, right? So in case of each and every single polygon for each site, I need now to be classified or dissolved by city name. So let's try and run, for example, let's back here. You can just back to the fields. Anything additional? We don't need anything else. This is just here if you would like to save it as directly as a permanent layer. Because whenever you run it, it will just create an additional layer here, but it will be temporary. So if you close your project, it will not be saved. So make sure that to save it as permanent whenever you are doing this kind of exercise. So run it now. So now I'm expecting to have this dissolved. It's already here. See, now it's called dissolved here. It's being already coming, but it's not showing here anything because it's coming in the bottom down here. So you can just hide, for example, this Voronoi polygon to see what we have. Okay, very good. So if you zoom in now, you'll find out each color, which is representing a city, different city, is now having a unique boundary or a unique polygon, right? So now, for example, we can just play around with the format to try to make it more clear. So let's first zoom in here and just to see what we have in a more clear way. For example, we have here different color having a different polygon. So double click, double left click. Then we can just inside here, we can just this one, the the symbol. I'll just select symbol fill. I just need, for example, the fill style. I don't need. I didn't need fill style. So I just make it clear. You can see this is how it looks like now. This one, for example, I can make it as gray or whatever color I would like for. It can be gray or even, yeah, for example, this one here. So I can just take this one here. I was just selecting this as a gray. Now it's coming like this. Then I can just increase the size a little bit just to make it more clear. So now see how it's changing here. This is how it looks like now. If you look up here, changing. So apply. See now how this is how it looks like. So now you have it even by city and the CV increase. So this is kind of polygon is now being created. And one more important point, that still, for example, you assume that you would like to minimize some of these border manually. For example, you need, for example, to change this border instead of this thing. So this comes to, if you remember the previous videos, we have this kind of toggle editing, right? If you click in this toggle editing here, you'll find this vertex tool, and you can just click here. You'll say vertex to current layer. So if you click this now, see now, if you're going any, it will just classifying this into different polygons as you can see here. So for example, if I click here, this point, but let's zoom in, left click, then I can just take it down here like this. Left click, then left click again. And again, you do that because it's like two layers being created. So you can even doing now the modification manually. Let's just close it now. So now we have changed it. So this is, you can do it for any of these polygons. The next step, let me hide this part. The next step, I need to give a label for this kind of polygons, just to know what is the city name for each of them. So you can just, again, in the solved layer, you can just rename it to anything you need. Just double click, double left click. It will be opening this particular thing. You can just go to the label. Then the label, you can just select a single label. Then can be based on your given data. For example, here under the value, this is based on your data inputs. You have only two things. Can be site ID or city name, but here we need to the city name. Then I'll just make a buffer just to give it more clear. And here I will just give yellow card for now. Just see. Now, if you click like this, now you see now city name is coming inside here. So now we have it very clear. So the second point, actually, if you would like to classify each of them, each even city or any other inputs by color. So this is, I think we already discussed before. It's just quick one. Double click again, double left click. So after here, you can see now it's opening again. So if you remember, we just go to symbology. Symbology usually used to categorize by color or even like make some modification in the format. So after this one in the top here, top right here, or the top middle, you find this single symbol. You just need to make it by categorize. You need to categorize it now. So you need to categorize it by color for what? First, you need to categorize by color by the city name as well, right? This one. So if you click here now, if you make classify the bottom here, it now will be classified by different, I see different, but it doesn't have a different colors because there is here this one. If you remember, I changed the format of that part. I changed it here. I make it no fill, for example, so I can just again do it as solid, for example, and again make like this. See, and now make it classify. It's now giving me a different colors here because I will give no fill last time. So now if I apply, what will happen? I'm expecting to have a different color for each and every single city, as you can see. And you can play around with the border and the formatting as we just discussed for now. So now this is, we reached into the first point. So now let's go to the second point, which is how to find the area of influence using Voronoi polygon as well. So as a summary for that part, to create the auto boundary, you need to use two tools, which is called Voronoi plus Dissolve tools. First step will be classifying your points into polygons. Then you need to solve these polygons based on the category or the attribute which you are looking for. So now let's go to the second part. So actually in the second part, this is what we are trying to reach. What is this? What you have it here? First, we need to identify something called area of influence, or for example, assume that you have some data sets. For example, let me show you what we already have now. For example, you have this kind of particular points, which is called traffic. So I'll just show you, this is where this kind of points, we need to create those kind of inputs using these points. So right click, let's see what we have, then I will explain from the data. Right click, then go to open attribute table. Under this part, you can see each of these points or polygons consisting of sites plus total traffic, revenue, or whatever you can call it. So now I need to try to find which kind of areas where it's having the highest traffic, which we can call it area of influence or area of generating highest traffic. So this can be used also due to Voronoi. Plus, on top of that, I need to classify each area to have a category. For example, pie chart that's showing here, which is showing what, okay, this was the total traffic. So I need to know what was the distribution. If you look into 5G, 4G, 3G, this is like this total traffic is being divided into three values for these technologies. So I need to know within these highest traffic areas, what was the distribution, which technology having the highest traffic for an example. So we need, for example, this pie chart idea. Then we can just give a label for this based on the site ID here. So actually, this is the data set which I have it. So I will just hide this one for now because this will not be our part. So now we have this kind of points in the map, which is each point representing a site and the site having a traffic. So we need now to convert it into this area of influence. So again, this is where Voronoi tool is coming into the figure. So if you remember for the previous, the first part that we mentioned that Voronoi will create a polygon for each and every single point. So again, here, if you make a Voronoi, if you could look into the Voronoi, double click, and under the Voronoi here, you find again selecting my traffic, which is my area. I can just run it. So now the Voronoi divided the areas into, as you can see, each and every single polygon, right? For each and every single point. Now the easiest way around to categorize this one, for example, by traffic, right? Which you already discussed it, if you remember, but it was bare city name. So you can just right click and go to reporters, or you can just double left click here. Like, so you can sound it's opening now. This is my symbology. So I need to categorize it now by, for example, categorize by traffic, right? So here the value, where it's showing my data, you'll find many inputs here, which is all the table attribute or attribute table. So you need just to, for example, check it by total traffic here, as you can see. So now if you make classify, okay, now it's seen, it's giving a lot of different colors. So this is, might not give the indication for what you're looking for. In this case, you need to utilize or use this kind of function, which is called color ramp. So if you click in this color ramp, for example, if you click here, you'll find that it's giving you different colors. For example, a range of colors. Here, if even all color ramps here, you will have many more as well. So for now, I'll be using this spectrum, which is starting from red till blue. If you like here, it's classified now my ranges. This is the traffic starting from 1.8, for example, till 7.5 terabyte. So this is actually starting from here. It's classifying from red till blue. But in this case, I would like to see the red as the highest value. So in this case, what you need to reverse this one to start blue as the lowest and red as the highest. So if you click here again, you'll find at the top here there's something called invert color ramp. So if I invert it now, I'm expecting that the highest traffic area would be showing, for example, from orange till red color. So let's see now what you have. This all other, in case if you have any sites with blank layer, it will giving be red. So this is also can be tuned. You can make it manually, or you can even remove it or hide. So now let's generate apply and see what you have. So as expected here, for example, you can see now we are getting now here is red color, right? And this is orange. So here, this is, for example, area presenting a high traffic. However, this site seems to having a low traffic, so maybe you need to look into this area. Maybe it's telling something that we might have a problem here. And in the top also, right, showing that this area also having a high traffic. And you can play around with the formatting. For example, let me first hide this. I'm just hiding the site ID for now. If you double click again, double left click as well, you can just play, for example, under here. This is symbology. You'll find, for example, layer rendering. If you click this layer rendering now, you can, for example, now decrease the opacity, for example, by whatever 58. Then you close it. Even you can now upload your maps, but upload to the Google Maps. So in case if you'd like, you can just take this one above the Google Maps. So you can just play around with even the Google Maps itself or with the opacity for that part. But for now, let me hide it to make it more clear for us. So this is how it looks like. For example, if you'd like to give a label for that part, you need to double click again, and it will be opening that part here. You see that we have labels. Under the labels, just select by single label. And again, if you recall it, we can just make it now instead of site ID, I need it by site ID, yes. And you can even give it by any other metric, but for now I need by site ID. Then I will just give a buffer quickly, as same as we did before. I'll just give it as yellow color. So I just click and I will apply here, and I'm expecting to get my here. So now let's get this kind of, remember, we need now that traffic distribution for each and every single technology. For example, if you remember, you click here, right click, go to the open attribute. You'll find this kind of site ID, traffic volume, and this total traffic, and then it's classified by 5G, 4G. So I would like to get the pie chart, if you can recall it, for each and every single site, and so see what is the current traffic distribution for technology. So how you can do that? It's the same way, just double left click here, then it would be opening this part. So under this part, you have many options here. So look into this diagram. Under that diagram, for example, usually it be coming as no diagram. So now, for example, select, you can see you have different options, tag, bars, pie chart. So I'll just select pie chart. And under pie chart, side open attribute. Usually this input is not here, so I will just delete it for now. See now, usually it comes like this. So for example, now we would like to classify or categorize the pie chart based on three things, right? Which is in this example, showing these three technology. So I'll just do like that. Then you have 5G, 4G, 3G. Then you can just here double click and double click in the color, double left click. It change the color, for example, this one to red. Then I need this one, for example, again by orange. Then I'll keep this one as it is. If I apply, see now still not giving any information. So in this case, you need to look into the size. So in this case, size is kind of you like there is two options, even fixed size or scale by a specific attribute. Since I don't have attribute to control the size, so I just select here, for example, fixed size. So for example, if I click now, see now it's coming very big. Now here it's being classified with color. Each color presenting, if you remember, presenting a technology. But in this case, you can see our site ID, for example, is now hidden under the polygon. So under the pie chart. So first you can, for example, reduce the size a little. For example, you can make this one. This depends on your preferences or reference whatever you need as a requirement. And now still the label, site label is not being shown here. So just quick note, if you remember, you just need to go to the label and the same term here. And for example, you need just to check this placement, change the location of this one. For example, you need the distance within this one. For example, let's make try 8 as an example. See, now it's coming here. It's coming above here. So now we can just click OK. And this is how it looks like. For example, now we know that if you look into the here, we have our the left side down here. You can see this is our legend. For example, this presenting the traffic, right, in the ranges. So we're expecting that the highest traffic is red and orange. So this up in the top right here, the area having highest traffic, and also this particular area. And this is a traffic distribution. For example, if you quickly look into that part, the blue area which having low traffic, as you can see, it's generating having higher 4G traffic, and the opposite way around. Whenever you find high traffic, you'll find that the 5G is having high traffic. So this is also can give a good visualization whenever you are checking something. So this was the second part. Now let's go to the next part. It's about the heat map. In this part, the heat map, how to generate a heat maps. So now I have this kind of data in the map, which you can see it. For example, I have points or dots or here triangles. So for example, if you right click here in this traffic heat map, and if you check this part, you'll find that, for example, what is our data? It's the same data set which discussed in the previous section. So this starts showing again site traffic and so on, this kind of distribution. So I would like to generate the heat map to check again the areas with high traffic, for example, total traffic, but using the heat map. This can be done. And heat map can be done for different things. It can, for example, identify the area with highest population or highest distribution of points. Depend on whatever you are going to check. So, for example, here I would like to check with a metric which is a highest traffic. For example, I need to check which area generating highest traffic by, for example, red color. So this is the dots which you have it. Each dot's like each point of each site, like showing this kind of point in the map. So actually, what we're expecting to get, I'm going to explain two methods of generating heat maps. The first thing I can get it's just this way around. You can get this kind of heat map. So this one presenting that, okay, the red color here showing this is area, these two area having high traffic, and above yellow also having kind of moderated traffic. All the others, which is blue, is kind of low traffic. This is one way around. And the second method, which I prefer it more, which is just one, is just showing, for example, this particular area having very traffic, high traffic, all, and this area as well. It's scan close for the other one, but it's just giving more exploration about that part. And in the top right here, for example, showing that this area also having high traffic. So if you compare, for example, both of them, you can see it's kind of similar, but the other one giving more clear figure. So this also will be based on your reference, what you are looking to do. Because actually, at the end, one of them, which is the second one I'm going to explain, is just by service. So you can get similar result by both of them at the end. So now let's just explore the two different methods which you have it in the maps, in the heat map creation. So now I'm going to convert this kind of points, which is representing one site and having equivalent traffic, into heat map. The first method I'm going to use is something called actually IDW. If you look into this processing toolbox and you search for something called ID, with something that's under this interpolation, you'll find something called IDW interpolation. So if you click this, double click this ID interpolation, it would give you this kind of window. As you can see here, first saying that this is names inverse distance weighted, and this is generate interpolation of each vector point, vector layer. And if you look into the data inputs which you're having here, first it's asking you what is your vector layer. So I'm going to use this traffic points. Then it's asking me what is your interpolation attribute. For example, if you have whatever metric, for example, traffic or whatever other thing, you need just to select the metric. For example, here I would like to generate my heat map or my vector or my raster layer based on total traffic. Actually, the main idea of this IDW interpolation, it will just convert these points into raster, a smooth raster. Raster means it can be an image, so it will be based on pixel, as you can see down here. So first, let's click here. Once you select the interpolation attribute, which is traffic, I just need to make plus and add it here. The second point here, that it's asking you which area you would like extent, at which extent you would like to generate your IDW image or the raster. So for example, here, if you click on this arrow, you will find that it can be based, you can draw on the map manually. And once you draw it, will give you here coordinates, or you can just use the current map canvas extents, which is the one which is have it here as a zoom in this part. Let's first try this one. Draw map on map canvas. So if you, for example, here, it will give you an option to draw. So for example, I would like to make here for this boundary, right? So once you do like that, it will give you a coordinates here. But for now, I will just use the same method, but here I'll just make it based on use current map canvas. So it will just give me the full screen here map canvas. So it's giving me here now the coordinates for this kind of map canvas. So now the second point that here it's asking you, okay, how many pixel you would like to generate. If you remember this pixel in context of raster data in general, a pixel is the smallest individual unit or element of a digital image. So if I'm going to generate an image, this would be the smallest point of this digital image. And the term of pixel in general is derived from the word picture and element. And pixel in general represent a single point on the raster grid. Once we have a raster or an image, this is representing a single point in this grid, and each point can be represented by color, for example, which we are going to use it, for example, to generate our heat map. So now, for example, this is just 2. I don't try this one. So I need just to change, for example, to try 0.001. So now it's saying, for example, it gave me this value. This is can even make it more less. You can have more pixels, more rows, and more columns. And this is depending on your laptop or computer processing. So this is will give you even more data. When you increasing the pixel size, this can give you more accurate information. So for now, I'm going to use this value, which is 0.001, giving you have around 1000 pixel and in the rows and columns, as you can see here. So if I click run, it might take sometimes more time. So let's see how long it will take. So now it's 99%. So now it's being done. And now there is a layer created called interpolated here. Let me just change the name first for this one to avoid confusion with the other existing one. I will call this one, for example, IDW underscore traffic inside. So now this layer here, this one is being generated here, as you can see. But as you can see, it's still not showing in the map. I need to do that because actually it's coming under the layer. If you look in the top again, layer orders, you find that this one coming under the Google satellite, for example. You just need to move the order here. So you can see now it's being represented as an image or raster, as you can see now. And you have different colors like black and so on. So now we need to convert this one into heat map or different colors. So how to do that? You can again, same method whatever we was doing before, double left click here, and it will be opening this under symbology again. You'll find that this render type, change this one from single band gray to single band residual color. Then you will find this kind of ranges. Now it's asking you again, what is your color ramp? I need my color ramp, same as, for example, based on this spectral, but I need to start with the lowest to be, for example, starting in vertical color. The lowest will be here blue, and the highest will be orange, red and orange. And the main point here that this is showing only only five categories. Can be controlled, and usually I don't use this mood or 5 fixed classes. I use another method, but let's first see what we'll get from here. And one more important point here, you can see, for example, there is different options. Seeing that what is the minimum value I would like to check. Usually it's calculated based on existing data, so take the minimum value, which is 1.1. Maybe there is something more, so this can be manually changed. For example, you can say from 0.5. So it will start classifying the data as it can do. So I'll just run it to 1.1. Here also the label itself is showing like a lot of digits. So you can just from label precision here, you can just change it, for example, to 1. So it will give you as a label. It will be much less here. So let's apply and see what we'll get. And bottom down here, you can just play around with the data formatting as well. So apply. See, now it's not giving me a kind of heat map here. Just let's click OK and come back for this one again. So now, for example, it's showing now, okay, this area is kind of yellow. This one also range. It's kind of similar to whatever we get before from the Voronoi right area when you define the area of influence. It's kind of similar. This is also a site was before was having a problem. So this is also another similar thing. But the main idea here that we have a different other methods to show this kind of other matches, which is bigger elements. So let me show you how you can do that. For example, if you double click here, just as for example, changing the formatting, you can see you have something here called mood here, this mood. If you make it quantile usually, as you can see here, it's asking you how many classes you would like to have. For example, here I have 5. Let's assume that I would like to change it, for example, to 8 classes. If you like this part, now change it to 8 classes. So now I have more classes even. So even you can make it 10 classes. So it give you here more colors. So if I click apply, for example, I'm expecting to have now, for example, more areas. Now I increase the red colors, for example, 3.8, 3.6. So I will have more extension here. See now here, yeah, it's showing like this. But as you can see that the background, for example, for the Google Earth is not at all showing now. So you can play around with all this with the formatting until you see, for example, here, how you can see this part. Now, if you would like to get an image to try to to have a little bit showing your Google Earth format, you need again to double click and start playing around with your this blending mode. This blending mode, usually I use hard light if I'm using the Google satellite. So if I click apply, see now how it looks like. It's like merging with the Google satellite. Let's see until it's true. See now, okay, very good. Now it's showing that, okay, this is your highest area, only this side having a problem, also here, and your Google satellite is showing in the background here, as you can see, for this area. So this is also one of the things I use it for the IDW interpolation. Now let's go to the last method for the heat map. Actually, there is another method, but I'm just going to show the most common used one for the heat map, which is very like easy one also. So the first method, as we summarized, as we mentioned, it's based on this IDW under the processing toolbox. So the last one, actually, if you go to this heat map, we have the points, this kind of points. You can just double click, double left click here, and it be showing here. So under the same, if you remember symbology, under the symbology you have before we use this categorize, you find if you look down here, you even having this kind of heat map. You have another options, but we are going to use this heat map now. And under the heat map, first is asking you again for the color RAM. So I will use the same color RAM, which we used it already, which is called the spectral. And I need again to reverse this one to start from blue till the red color. And here it's asking you for the radius. And this radius, for example, for this particular point, how much radius you would like to increase. So the more the radius, the more the areas which being showing was, for example, even blue or red or yellow color based on the area how it being. So I will start first with 20, for example. Now it's asking you if I generate it like this by default, it just will select the areas which having the highest contribution or high points. For example, if you assume that you're using another data set which having many points in the map, it will just go in and check these points based on the points contribution or point distribution in the map. So the areas with highest point distribution, it will be representing in red color, and the vice versa whenever you have less number of points. So for example, now, no, I would like to weight my points by, for example, here in this particular example, same as we mentioned, by total traffic, right? So I need you to look into the points and try to give me the heat map based on the metric, which I give it here, based on total traffic. And by the way, this is also can be like a formula. You can, if you click on this one, you can just give a formula. For example, you would like to categorize based on the traffic greater than a specific value. For example, greater than 2 or whatever, as example here. So it will be showing this kind of information. So for now, I'll just give this one discard of change. I'll just give him this one. Let's apply and see what we'll get. See, very good. So now I'm getting this kind of information, which is showing that, for example, this area having traffic, this one as well, and this yellow areas, but it's not very close to the other, and this is can be controlled. For example, if you remember the other one, if you click here, it's showing more red, as you can see. We can try to get this one similar to the other as well. If you double click here, and under this double click this part, you can, for example, now, not sorry, not the traffic heat map here. Under this part, for example, you can show that, for example, 40 radius. So I'm increasing this radius area will increase. You can see now it's being increased more. So it will get, as long as increasing the radius, will get closer to this IDW method as well. This one, for example, here, if you look here. So yes, one important point, usually when you run it, it will not come like this. It will come with something, but I applied this before starting this kind of part in the video. So for example, when you apply it, you will see that most of the background will be blue. The Google Earth will not be showing. Why? If you look in this layer rendering part, and if you check this opacity, usually it's like by default it's 100%. So if it's by 100%, this is what you are expecting to get in the beginning. You hold the map, which is having no values, it will be showing as blue. So if you'd like to get, for example, the background of the Google Earth, in this case, see the Google satellites being shown, hiding this one, you just need to double click again. And as we just mentioned, to go to this under the symbology, heat map, layer rendering, and change, for example, the opacity to 50% as an example, or even less, depend on what you need. So if you click like this, now it will be showing this kind of map. So, and this part actually now, this was how we can do the heat map. So as a summary, it can be done for the symbology, in symbology heat map, or using this IDW tool, IDW interpolation, which I prefer more than the other one. So now let's move to the next part. Assume now you would like to get a histogram with your, for example, traffic distribution. So if you double click here, it's just additional option, you'll find something called under this symbology, and you have something called histogram here. If you look into that part, it's showing here compute histogram. Let's try to click and see what we get. See, very good. See, now it's giving you the frequency. For example, the x-axis is presenting your traffic from starting from 0 to 1. So it's just giving you that, okay, this particular range from 3 to 4 is presenting this the traffic which you have it based on this side. So we know that this is kind of our histogram we can do, and even you can control the minimum and maximum value, and after that you can just export it to an image, and you can use it also for your reference. So there's also an option under this IDW which where you can generate a histogram for your data which being used in the map. So that's it for the heat map part. Now let's jump to the next part for the remaining of this session, which we discussing this how to create a grid or even hexagons, which is very very useful and many exercises. I will be explaining the use case of this part. So let's move forward. Now let's start with the second part of this session. Actually, this session will be speaking about how to create something called the nest area or even create grids, in other words, or in other words, we can call it how to make clustering or even sampling or binning. What it means by all of this? Actually, first, let me tell you one thing that we will here merge or go through practical examples from many of the things we have learned in the previous two sessions in this particular exercise. So for example, assume now you have this kind of points in the map, these points representing, as you can see in the bottom left here, that each point representing a particular speed or test, like assuming that this is being tested and done in the network or data being provided and it's randomly in random locations. And each point is representing a speed. For example, the red colors representing and orange representing speed from 0.1 till 5.7. And this blue color representing 28 up to 265 as an example. So the data we can see it here in this particular area, for example, visualization point of view, it's not representing, I cannot identify which kind of areas having a low speed or better speed or which areas need optimization. So actually, in this case, we can go for the grass part in order to create something called, for example, a study area. So where we can need to have this kind of sampling and data collection, where the grass can assist in systematically sampling or collecting data across the study area. So we can create small clusters here to be able to visualize and to be able to identify the worst areas in terms of speed and so on. And this is also can be, for example, very useful in term of data comparison. For example, if you like if you did any changes and you would like to compare between different days, so in this case you will have your cluster already fixed, and any points within these clusters can be aggregated, and this is also one of the function of the grids and other function we are going to explain. For example, if you create small cluster, let me show an example what we are going to reach into. For example, you have this called join layer. If you look into this, this is will be how the final figure will be look into, that we can create a grids or hexagons as shown here with any size. Like for example, 100 by 100 meters, 150 meters. This one is showing 100 by 150 by 150 meters, and you can see each hexagon is representing a particular speed. For example, the red one from 0.2 till 2.8. Any sample falling within this kind of hexagons, you can take the aggregation of these samples, and you can identify the aggregation whether you take the mean, the maximum, or whatever. So here, visualization point of view is very easy now to identify the best areas and weaker areas. For example, here I know that this red things it's having a very low speed where I need to look into. So now let's start to explain from scratch how we can create that. And as I mentioned to you, it will be very, very useful to have a practical examples about many of the things which being explained in the previous two sessions. So now let's start from scratch now. So now here we're going to start. So now I have uploaded my data sets into a new template where we're going to start from scratch. But I just uploaded this kind of points and I just make a categorization just to see the colors of each and every single point. So first, let's explore the data which you have to have more understanding about what kind of data sets we're going to work with. So right click, open attribute table, and this is where what we have here. For example, here you have each and every single point here in the map is representing a test, like downlink speed, downlink and uplink speed test here, and this is being done in different days, as you can see, for example, 8, 10, 11, 12, and so on and so forth. Okay, and here even representing the technology which is being done for this particular test. So now we need from this kind of data to reach into this kind, creating a small grids or hexagons where we can identify the best and the areas which require optimization required to take it into the next level where you can start like finding the worst or outliers area where it need to be tuned or optimized, as we mentioned. So the first part we would like to do actually, as you recall, the first part here, you just let's zoom in here in this particular area. So in this part, I would like to create a polygon to cover this area. If you remember, the thing you need to do, you just can go from layer. If you remember from the session, then you will get create layer. Then we'll go for this new temporary scratch layer. Okay. Then let's call it, for example, clusters. rasters. Then the geometry for that part, it will be as polygons, as we did before. Then we can just do here, call it, for example, name of the polygon, in case if you need multiple polygons. But at the end, we'll just create only one. So now let's click OK. So now we have something. Now we need to enable the toggle editing in the top left here, as we mentioned before. Now we just need to go here, add polygon feature. Then we can just manually start drawing our polygons. We can just manually. So yeah. So I just completed the polygon creation around this area. So actually, this is the first step. Now we would like to have a grids with you between this. Define the grids, customize based on your reference, what kind of size you would like to define, to just try to calculate our points which being falling within here. So now we need to use a tool in this processing toolbox, which is called grids, create grids. So if you search into create grids, for example, you'll find it under vector creation. There is something called create grids. Now let's look into this one. If you double click here, then here you will find this kind of parameters. First part, it's asking you what kind of grid type you would like to create. Here, this is a grid type. Can be any of those types. For example, hexagon, diamonds, rectangle, line, or whatever you need. So in this example, I'm going to use hexagon, which is representing a polygons. Now it's asking you what kind of grid extent you would like. So usually we do this manually, or even you can take the map. We already explained something similar to this before. So I'll just click here in this arrow. I will just draw on map canvas, as you can see here. Then I will do like that here, and I'll just select, for example, this particular area. Here is giving the coordinates of this area. Now, the most important part here, which is actually require a good focus for this part, is asking you about the horizontal spacing and vertical spacing. This usually, if you want to define in meters, you need to change your coordinate system. Let me explain this part. First, read this kind of here, this part, is saying that distance in the geographic degree, consider your project in the project local coordinates for accurate results. Here is telling you that currently your project is working in geographic degree. Actually, this geographic degree is my current system, which I'm being used here, is called EPSG 4326, and this is actually known as WGS 84, and this is a geographic coordinate system that uses for both latitude and longitude. This is our project coordinates. So it's not using like meters and so on, in meters or units. So in this case, you need to change this kind of thing. So you can even change the complete project, or you can just go from here. This EBS 43, the WGS 84, you need just to change it from select your CRS. This is coordinate reference system. So you just click here. Here it will ask you about what kind of format or coordinates you would like, coordinate reference system you would like to use. Let me explain to you. You have two different types of coordinate system. The first one, which you already explained, which is called, we usually call it this WGS 84. And you have another something called UTM, for example, the WGS UTM zone or UTM. This UTM actually, it's like a projected coordinate system that you use units are typically the units are typically used or measured in meters, and it divides our Earth in general into zones. And U2M usually is very well suited for this. Any require like any area or task that require accurate measurement of distance or area within a specific region, for an example. So now, for example, this area here, which I'm showing you, is located in Saudi Arabia. So I would like to find what kind of my coordinate system in terms of UTM, what I'm using. I know it's 37N. I will explain how I got this, and I will explain how you get it for different area. For example, this 37N is referencing for Jeddah. This 30S, for example, is referencing for Malaga. I will explain to you how you can this kind of things. You can identify from Google Earth. And this is very important to locate, whenever you do a project, to locate the correct UTM system to give you an accurate result. So for now, I'll use this 37N, which is representing my kind. So I'll just select this one, and I'll go back here. Select this one, and I will go back. Now here, change it to EBGS. See, now you can see now the units changed it into meters. Now it's fine. So now I would like to create it, for example, 150 meters and by 150 meters, as you can see here. Then I will run it. Okay, now let's close it. If you look into the background here, in the background here you have many hexagon lines being created. Even if you zoom in, and you try, for example, to check now from the top here, the measures, like what kind of the line or distance we have it in this area. So for example, let's select and see how much we have. If you look into bottom right here, we have in the bottom right, it was having 150 meters, as you can see in the bottom right here. So let's here take it here just to be more clear for you. So click, for example, here. See, it's showing like 150 meters. So this is actually representing whatever we have created. Now let me jump to the Google Earth just to explain how you can get this UTM system whenever you do this accelerator, which is very important. Now I'm opening the Google Earth, as you can see here. Now I just quickly would like to know, for example, what is the Malaga UTM, which I'm going to use. Let's search for Malaga and jump into Malaga, and let's see what will. Okay, now in this Malaga, if you look into, for example, select any single points here. If you look into that part and just, for example, take it here or anywhere, just make OK. Now our coordinate system, if you go to tools option, is based on decimal degree, right? So this is not representing the UTM. Okay, the UTM is called universal transfers. This is where you need to know in order to get it. If you just click it OK for now, and then you click apply, then OK. Then here, you just click again in any points in the map, which you have it in this location. Right click, properties, for example. Then you will like here. This is now it's saying easting, northing, and this is like representing in meters. But your zone now is 30. But you need to know what is the Earth hemisphere in this part. So how you to do that? Just go to the view, so you can look into the longitude. If, for example, your longitude in a negative value, this means you are in the south. This means your area will be 30 south or 30. If it's the longitude and positive value, so it will be the zone, and positive values representing something called north. So, for example, it would be 30N. So this is now I identified, for example, for Malaga, it's 30S. This is the same which I have done for the previous area, which I mean dividing as called 37N. So now let's go back to and continue with our working. So now going back to the map, let's load again the points which you have it here inside this one. So we have this kind of points, and if you remember, we already created the polygon. So now I would like to have this hexagons only within this particular area, and then within where the points our points is being falling inside. And here where we need to use another tool, if you remember, it was called select by location. If you can recall it, this select by location, it was on the top right here. This was in the previous second section, where second section or second session where we explain it. This select by location, if you click it here, this one, select by location, and this is under the selection toolbar here, this one, you click here. So now this one is saying, okay, which feature you would like to select. For example, I would like to select based on the bigger cluster, right? So let's select the bigger cluster, what's called the grid. I will just select this one, and you would like to compare it with which feature, for example. So I would like to compare it with the small polygon which have been created, which is called the clusters. This one, the yellow one inside. So, for example, clusters. Then I would like to select the intersect between both of them. So if I run it, I'm expecting that this inside the polygons or the hexagons will be only highlighted within this area. So let's run it and see what will. See, very good. See now, it's just highlighting anything from this polygon intersect with the hexagons or the grids is being highlighted now inside here. If you hide this one for now, and even hide the points. See now, this is the selected area, which is being created now inside this kind of grid. So now let's export this selected area, the one we would like to work. For example, we have our points being falling inside this one. So let's export it to have it as a permanent layer and also to use it as itself. So whenever you go for the export, remember to save selected feature as. So just select this yellow part here. So just click here, save selected feature as. Then, for example, let's save it here. We call it, for example, selected area. I'll just give it the same name which we have it here. Then I will click OK. It's asking me to overwrite. Yes, I would like to overwrite this file. So now it's being created. So if I highlight this one, now it's being showing our selected area, which used by the select by location or select by location. Yes. The next part, if you look into this point, now we need to calculate, right? For example, within each hexagon, what is the average speed which we have it? So we need to make like this kind of calculation, like to have this kind of grid to join the attributes, for example, to join this hexagon with the points going inside. And here where we have another tool in the tool processing toolbox, called join attribute by location summary. If you look into this part, join attribute by location summary. This is giving you a benefit to having a join between different layers, and you can even give it based on attribute or a field, and you can give even a metric or a calculation method. Let's double click and see. So you are double clicking here, then you have this kind of join attribute. Then which feature you would like to join? I would like to select this selected area, right? Which is already being saved. Again, we use this same function called intersect. I need to compare it with what? I need to compare it with the points, right? Where we need to calculate the speed. So here you have it. Then you have the downlink speed here. And under the downlink speed, now which field or you would like to summarize using which one? So if I click the three dots now, it will be showing my table information, which I need to summarize, for example, by any metric. For now, I'm using by downlink speed, correct? Then I'll go back. Then it's here, it's giving downlink speed. Now it's asking you which summarize to calculate. So if I click here, it will just give you, for example, here some calculation method. For example, the count of the samples, the minimum, maximum, average, whatever you need. So I will be using mean, for example, here. Then I'll go back. Then here you can just discard records which couldn't be joined. For example, any records falling outside. So just click this one in case. Then you can run it. Then let's see what we have got. Let's hide this one. So now we have this kind called join layer. Now let's try to do one exercise. We have already, this is the final image. Even if you compare, you will find that some of the hexagons is not being, for example, here, this particular one is not showing anything. Because if you look into the points, you will not find any points falling inside. Here, for example, there is no points. That's why it didn't create, it's reduced even more for our hexagon. For example, this hexagon also is not here because there is no points falling inside. So now let's try to categorize it by color to identify the areas where it's having a low speed. So what we need to do, the same, which you have done before, double click, then you will have this information under the symbology again. You have the single symbol, right? Then under the single symbol, you can use categorize or you can use graduated. The difference is between both of them, the graduated can give you control over the range that you would like to do. So I will use graduated one. And here, for example, you can have a color ramp. So I will use, for example, this color ramp, which is spectrum from red till green or till blue, which I'm telling them I need to see the low speed as red color and high speed as blue color, for example, or green color. I can change that this part. Then here, the value, right? We need to do it based on what? Based on the speed, right? Which is mean, right? This is our calculation. Then you do classify. See, now it's giving you different ranges. Here, even you can increase it more. You can make it based on 7. Here it's increasing. And you can even do manual change here. You can do whatever range you would like to double click. Then you can just give manual. You can just give any manual ranges you would like to do or react to. And here also you can do some changing in the colors. For example, assume I don't need a blue. I need, for example, a dark green. For example, here, for example, this part. So I will change this one to dark green as an example. So here we go. So now let's apply and see what we'll get. Okay. Now here it's showing here. Let's just take this in the layers above. Let's take it in the top of the Google Earth layer. See now this is how it looks like. So this is, if you look here, this is mean the small hexagons. This is showing a very low values, for example, 0.9 to 4.1. And it's also the green one showing that the dark green is showing that this is having high speed. So this is, you can identify easily your areas and you can control the hexagons based on any grids. For example, 20 by 20 meters, 10 by 20 meters. So this is based on your requirement. You can just do this kind of things. The last part I would like to explain to you, for example, the same exercise can be done, which can also be very useful in case if you would like to have facilitating your data comparison. Assuming if you look into my original data sets, which is called downlink speed, this original one, if I go open attribute table, for example, in the last column here, you find something called benchmark or BM. This is having pre and post, okay? So for example, this means I have some testing being done in pre and post where I take an actions and I would like to compare now the pre and post results. So in the initial, which we have it as a single point, it was not comparable because the points was being randomly. But if you create already has a hexagon like that, in this case, you can create the same exercise which I explained through filtering first your data, for example, for this downlink speed. For example, you go filter here, then you go to the benchmark sample, for example, then you give here, as we explained before, double click here, then you make OK. Then, for example, you filter this one as pre, then you make OK. Then you can just, for example, here, so this my data, this is my pre data. So now I can again repeat the same steps which being explained, create hexagon for this one, then I can duplicate this one and make a new one, filter again. Then in this filtering, you can now again change this one, for example, to post the low bottom value. If you confirm this one, just benchmark sample. So you have only B here because we are just filtering this one. Let's test it. So now it's working. So even this one now, it will be falling in different locations in the map. It's just showing down here. That's why now it's not showing the results. I will just take it up in the layers. So for example, here we have this different location sample. So it will be even now more easy for you to, after you create two different hexagons, you can now calculate the delta between both of them through, if you remember also one of the methods we explained it before, through this properties, right click here or left click. Then you have this kind join field. So you can join both hexagons based on, for example, the or any other thing. So you can calculate the delta. So you can even having to identify which area being improved or degraded and whatever. So this is also one of the use cases, very useful use cases, especially for the benchmarking point of view. And this is will make it more easy for visualization. So we are done with this part. Now let's jump to the last part of this session. This will be the last part of today's video and of the complete QGIS guide. Actually, after you completing this, the third video, I believe this will take you into advanced level. In case if you require more videos about more functionality or more functions in the QGIS, you can just drop it in comments and I might create a short videos for it, just to clear any additional information in case if you need any more requirement. So actually the main here topics we are going to cover, which is listed in the top left, already discussed in the beginning of this video. So actually what I'm going to do in the first part, I would like to show you, for example, how you can calculate the distance between two different datasets. Assume here, for example, you have these blue points. Let's hide this sector for now. You have the blue points and you have the red points. I would like to calculate the distance from the blue points to the red points, or the opposite way around, depend on whatever you need. So this is, for example, can be used if you would like to calculate the distance and intersite distance between different sites, or even up to 5, 4, 3 sites based on whatever requirement you're looking for. So in this case, you can just go to the processing toolbox. Under this one, there is a tool called distance. This will find the actor vector analysis. And if you double click here, see here what's asking you for. It's asking you for what is your input layer. So for example, I would like to create from the blue points, and let's explore this kind of information first, just to see what you have. If you right click here on the blue points, just open an attribute table. So if you look into that, you have many information here. For example, you have the code 10003 and so on. So if I take this one as a source layer, I'm expecting to get the nearest distance from this particular point to the other points. For example, the blue points 1003 to the others. And if you make this one minimum, for example, here is an option asking you how many target points you are looking. For example, if I give 2 target points, so I'm expecting to get 2 points, 2 distance from each of these segments. For example, 1003, it will give 2 points from the red one. So let's see this red points. For example, if you right click here, open attribute table as well. So this one just showing that we have in total 17 points. So if I give 2 points from the other one, I'm expected to get at least 2 out of these points. So let's now select our tables. For example, this input layer, I need to get it as a sector addition, which is this blue dots or blue points. Here, let's take it on the right. And the unique, I need to get it by, I need just to list it, for example, in my new table. This will generate a new table. I need it by code 2, which was showing 1003, for example. And the target points would be this blue dots, or red dots, sorry, which is called points here. Then it's giving idea. So I need the first 2, for example, the nearest 2 points here. So let's make run and see what we'll get. Once you run it here, actually, you'll see that in the bottom left here, you will find a new sheet was being generated here called distance matrix here. This one. If you right click and open attribute table, you'll find that this one now, as we expected, you have this input, which is called 1003, for example, and the nearest 2 IDs, target ID 7 and 8, and here is giving the distance. And for sure, it will be repeated for the others. And since it's within the same location, it will give almost the same distance here, or the same distance, exactly the same distance here. So this is actually the benefit. And as I told you, you can use it, for example, to calculate intersite distance. And here you can just close this one. And if you need it into, for example, CSV file, you can, if you remember, right click, then you go to export, then save feature as, and you can just change the format. Then the format to CSV an example, then you can just take 3 dots and export it to any location you would like to take. Then this is the first point. The second point, assume now you would like to draw lines, for example, from this points from 1000 to, for example, this red dots, and to calculate the distance as well. So this is also another method, which is, if you see here, method to draw lines, We have many different methods, but here I'm going to explain two. First one called to nearest hub, for example. Nearest hub. See here, it's called distance to the nearest hub, line to hub. So let's click this one, double click, and see what we'll get. Again, it will ask you for similar information. What is your source point layer? For example, let's give the opposite way around. I would like to calculate from the red to the blue. So I will take the here, the points, and the blue one, which is called sector addition. So actually my hub now is the sector addition. So I'm expecting to get the source layer as ID for these points into toward this hub. And here you can just define the meters here. So this is based on meters to get the calculation or distance based on meters. So if you run it now, you will get a new sheet here called in the bottom left here. Let's close this one, called hub distance. Right click, make open attribute table. See now, this is what I'm expecting. That for example, ID1 we have 2000, and this is the nearest point. And the ID2 I have also 2000. So it's calculated for each point. The For example, this one you can see here, it's having many surrounding points. So these all points are being calculated towards the 2000. And the same here for 1000, for example, there is 2 points giving the 7, for example, this one and this one, showing you what is the distance toward this one. And this then for 9,000, for example, it's showing 3 points, this one and this one and this one. And the 4,000 showing, for example, here you can see 1 point and so on. So just giving the nearest for each and every single of these red dots towards the blue dots. And you can just even make it the opposite way around. Just you can just change it within the tool. So this is actually the idea. And this is not only calculate the distance. There is one thing I didn't show to you. For example, we have two sheets being calculated, right? The first one called hub to distance. Hub distance, which is the first tool you use it. Right, let's take this one to the top and see what we'll get. Hub to distance. See now here, yes, good. See now it's here showing that being created the lines from the dots toward the side. So this means those dots is being, for example, served by this particular site. And same here, these dots by this particular site, and these dots by the, and so on. And all these red dots served by this blue dot as well. So this is actually one way around. And you have another method called shortest to line, shortest, for example, here, shortest line between. This is also between feature. This is giving similar functions. For example, double click here. Again, it's asking you what is the source and what is the hub distance, source and the destination layer. For example, my source layer, let's again take the point, same exercise, towards, for example, the sector, let's say sector points as well here. The good point is that what it's working also with polygons. So this is also good points here. So for example, here I'd like to calculate the distance to the nearest point on the feature. And what is the maximum? Let's give the maximum. For example, let's say you can define, for example, how much you'd like to get. So I will just say, for example, 2, or let's give it a 3. And let's see what we'll get if you run it here. Okay, let's first hide the old one, which is called hub to distance. And let's now take the shortest line to the top and see what we'll get. See now it's because I gave three, for example, it's running, as you can see here, lines toward this one from the red dots toward the blue dots as well. So you can see. And if you right click here, make open attribute table. Let's see what we get as information. See, this is the ID. The ID is being repeated to each of those sides and calculated the distance and that, but the distance here is being calculated in degree. So this is maybe you need to do some conversion towards meters. So yeah, but I prefer to use the other method, which is called distance to the nearest hub. The next point I would like to highlight you about, for example, assume you have this kind of polygon and you need to create a buffer, and this buffer might be required for any few requirements or any request or task. For example, the buffer area, assume this one red one which I been calculated here. Here, for example, calculated was a smaller distance here. So this is, you don't need to do it manually. You have the polygon, so you can just go use again for the processing toolbox one tool called buffer. If you just click here buffer and double left click, then you, for example, here will give you information what is your input layer. So my input layer will be this polygon, which is yellow color. Then I will select this polygon. And for example, here, this is in degree, this one in degree. So you just need to try until you reach to your target. For example, I'll give it all open 2, then I'll keep everything as it is. Maybe this one end cap style, which is the surrounding, I can make it as a square, for example. Let's try. Then I can just, let's run and see what we do. this one buffer created in the bottom left here, you can just rename it whenever you need. Then you can just take it to the top. See now, it's giving you almost same, but let's hide this one and this one. Let's now try to modify the formatting. Double left click, see what we can get. I also need to close this one first. Double left click. Then here I need, for example, to remove the fill style. I just need to make it no brush. Then this one for the style, I will keep it as it is, which is black. Then I'll just take this one as heavy size here. You can see we have it already surrounding here, and still you can increase it more. For example, last time I make it open to 02. This time, for example, you can make it open to 00. For example, 3, and also this one, and we can, for example, try to change this one and see what we. So, for example, here let's keep this one on the bottom right here just to see. As example, you can see there is also another additional buffer called here being just let's rename the first one to be in the to be able to differentiate between both of them. So I'll just call this buffer 1. Then buffer 2 is here now. Let's try to second see. See now I increase the buffer area. So you can keep playing with the parameters which you have it here in this area. For example, change parameters. You can keep playing with this parameter segment and distance until you reach to your requirement for the buffer selection. So let's hide this part. And actually, now the last part I would like to explain to you, which is quick one. In case you would like, for example, to draw some plots. For example, I have some data here which if you remember from the previous session as well, this is coverage here, this kind of coverage which we have. Let's assume that you would like to get the histogram for this kind of coverage. So you can see I just searched in the top right here processing post for processing toolbox for something called plots. For example, you have this, for example, let's say vector layer histogram. Let's click it. In this vector layer histogram, it's asking you, okay, what is your input layer? My input layer, for example, not the buffer. I need to get this kind of coverage points, which is called N1, this one. And I need my attribute, for example, to be the coverage. It's asking you how many bends you would like. For example, I need 5 bends only. Let's see what we get. So if you double click this one, let's see what we'll get. See now it's giving you like this kind of histogram. And actually you can see this is your ranges for the coverage and the x-axis. But if you go back, so for example, let's change the parameters here. So for example, I can give it as 20. Let's see what we'll get. Run. So again, it will give you another input here. Double click again. So it will be started changing again. If you compare these two, it's having now less inputs. For example, this is more inputs here. So you can just keep playing this one, and you can just export it into image, for example, from here, or take a snapshot and so on. This is just a quick one, but we don't usually use it a lot. So, but in case you would like to check. Actually, this was the ending of this, the complete QGIS guide. This was the ending. I hope if you like the complete contents for QGIS, to share it with your friend and to subscribe to the channel and to share and like and drop a comments if you like and if you need any more requirement. Thank you a lot and see you in next video.